What is going on, everybody, and welcome to another video. In this video, let's take a look at Krichoff laws. Krichoff laws would help you a lot when it comes to analyzing circuits. So the first one is Krichoff current law, and it basically states that the sum of all the currents merging into a node is equal to 0. So if you take a look at this formula here, all the currents coming and leaving from that node are equal to 0. Or the sum, the algebraic sum of all the currents coming and leaving the node is equal to 0. So in this case, we have 5 wires merging into this node. So we have 3 currents. We have I1, I5, and I4 coming into the node, and then we have I2 and I3 leaving the node. So when we express this in a formula, notice that I1, I4, and I5 are positive because they're coming into the node, and then I2 and I3 are negative because they're leaving the node. So this sum, it has to be equal to 0. Okay, so that is the first law of Kirchhoff. This is the Kirchhoff law of current. And the second one is Kirchhoff voltage law, which basically states that the algebraic sum of all the potential drops in a closed network is equal to 0. And a closed network means a closed circuit. So here you have E1 and E2. They both power supply. They are a source of voltage, energy. And then the drop of voltage, the potential difference across each component in a circuit, the sum has to be equals 0. So in this case, E1 and E2 are source of voltage, but notice that E1 is positive and E2 is negative. Also notice that B1 and B2 are negative. This is B1 here, and this is B2. Notice that there is a positive sign here and a negative sign on the other side of the resistor, and that means that every time there is a drop of voltage, you have to subtract that to the total amount of positive voltage. The source of power is the positive voltage, and the drop of voltage across these devices are negative, and the sum needs to be equal to the value of 0 in this case. So E1 is positive, B1 is negative, B2 is also negative, and E2 is also negative because notice the polarity of this power supply. This power supply, the positive is facing in this direction. So notice that the sign of the arrow, that's the current flow. The current is flowing in this direction. So if this power supply has a reverse polarity, just like this one here, just like you have to look at it as a drop of voltage because it's facing in the other direction. Notice that this one has positive, negative. This one has the positive is the other side, and so is this one. Okay, so that is why it's represented with a negative. So when you solve this, that has to be equal to 0. So let's go ahead and do a couple of exercises. Let's do first the Krichoff law of current. Alright, so the exercise says determine the unknown current in each circuit. So in this case we have We can, I know it's a little bit tricky, but you can represent this to be something like this. This is the node. You have one current coming here. You have another current coming in this direction. You have one leaving and one leaving in this direction. So you have two coming in. Actually, we don't know if this one is leaving or coming, but we know this three, and we need to calculate this current here. All right, so we know this one. Let's do the formula. So we have 1 amp plus we have 1 amp plus 2 amps minus 1.5 amps, and this is equals to, let's say, and in I4, this current here is equals to minus 1.5 amps, and it's leaving the node. Okay, because remember, the sum needs to be equal 0, so it is actually 1 amp plus 2 amps minus 1.5 minus 1.5 equals 0, right? So this one is leaving the node, and the value is 1.5 amps. All right, so let's do this one. This one can also be simplified. These two nodes here are basically the same node, so you can say that this is basically this one here. So you have one current coming in here, another one coming in here, and this one is leaving, and we need to calculate this one here. Let's go ahead and do the same thing. So we have 200 milliamps, they're all milliamps, plus 50 milliamps minus 35 milliamps equals, and let's name the other one I4. We need to calculate that one. That is 200 plus 50 minus 35. That is 215. Okay, so I4 is equal to 215 milliamp, and it is leaving the node, flowing in that direction. All right, so that is for the Kirchhoff current law. Let's go ahead and do a couple of exercises for Kirchhoff voltage law. All right, so it says determine the unknown voltages in each circuit. Let's do circuit A first. So here we have 3 power supplies in series and 2 resistors. So we have 2 drop of voltages here. These are positive drop of voltages, and these are negative. So the 3 power supply combined are 1.5, 1.5, and 1.5. So we have 4.5 volts of the power supply. And notice that the resistors are connected in series. So there is only one current flowing in the circuit. You have one drop of voltage here and another one here, and we need to calculate this drop of voltage on the 330 ohm resistor. So first let's calculate the total current flowing through the circuit and the total resistance. The total resistance, given the fact that the two resistors are in series, is R1 plus R2. And this is equals to 470 plus 330 equals 800 ohms. So now let's calculate the total current flowing through the circuit. And that is equals to voltage over resistance, and that is 4.5 over 800. And how much is that? 4.5 over 800, and that is equals to 0.0056 amps or 5.6 milliamps. This is equals to 5.6 milliamps. So now I'm going to calculate the drop of voltage across this resistor. Let's name this R1 and R2. So BR1 is equals to R1 times the total current of the circuit. There is only one current. So this is equals to 470 times 5.6 times 10 to the minus 3. All right. So let's see. 5.6. Actually, it is 0.0056 times 470, and that is 2.6 volts. So VR1 is equals to 2.6 volts. And so we arrive now to the Krichoff voltage law that says that the algebraic sum of all the drop of voltages is equal to 0. So we have 3 positive. I put it over here. We have We have 1.5 plus 1.5 plus 1.5 minus the drop of voltage on R1, which is 2.6 volts, and this is all equals to VR2, the drop of voltage on this resistor. Okay, pull the calculator here. So it is 4.5 minus 2.6. That is actually 1.9. It's actually 1.8. The number is much bigger than this, but let's make it VR2 is equals to 1.9 volts. Okay, so if you plug in this 1.9 here in this equation, it should be equal 0. Let's do the one on the bottom. We need to calculate the drop of voltage here. We have only one current flowing. So we have 18 volts and we have a 3-volt power supply, but this one is a drop of voltage, so it'll be 18 less 3 volts, the total voltage in the circuit.